Alright, what's up everybody? This is Spartan Movex Forever and welcome to something more about multitasking. So today we're going to talk about how to correctly activate and test your autonomous with a single click of a button anywhere on the robot. Can be on LCD, can be on your driver control, the controller, can be a little button on the robots that's like a bumper on the robot. Press a button in the driver control mode and you correctly activate autonomous without any glitch, which is actually not that easy as it sounds, because I do think it is a multitasking issue. It is a topic that falls under multitasking, and these are just the things I copied from my LCD tutorial. And if you don't know about these autonomous selection and stuff, just go check out my LCD tutorial videos. And the link, I will put the links on the bottom in the description. Well, I kind of want to ask, like, let's start a talk from here. How do you usually activate autonomous? I know that if you don't have any experience with our with multitasking, or you don't even know what multitasking is, and neither do you go mess around with things like here and you add some sort of weird stuff to activate your autonomous with the toggle of a button. Usually, I assume that you would either to activate autonomous with the some feature here, which I cannot find because I didn't download the robot for some reason, or with a little simple competition or a simple field competition switch, or I think that's what we call it. A simple competition switch there are two toggles. You toggle between the disabled or enabled the driver control autonomous, which is okay, no problem. I guarantee that if you use that, you're not gonna get any programming errors whatsoever. But it's kind of, don't you feel that when you're driving and you're testing autonomous, there's always a piece of extended board from your driver from your controller, and that's not the neatest or the most convenient way to activate autonomous. So today I'm just going to talk about how to correctly activate the autonomous with a click of any button. So we know that the duration of autonomous is 15 seconds, and I'm talking about in the case where you just have a controller hooked up to the robot. They can communicate, nothing else. No driver control, no communication to the computer, no communication to the field control, no plugging into a piece of competition controller. So how do you do that? Usually you would say that in my driver control I might have a bunch of motor mapping. However, under your motor mapping, what you want to do is that you want to type, somehow you say that if I press a button, if the say that the left shoulder button, which is button 5U, I believe, if say that VEX RT BTN 5U. Let's just say that one of the shoulder buttons is pressed, which let's change this to 8U about that, because usually you need the shoulder buttons for the lift or some sort of feature. If that is pressed, I want to say that somehow start autonomous, something like that. You'll probably think that, and we know that autonomous is a task. If this is void, I can just say type autonomous, but this is unfortunately it's a task. That's the way that Robot CD decides to do it, and it does have its grounds to do that. So let's go and start task. Say start task. Start task. Autonomous. Which is something that looks pretty valid. If I press a button, I start a task to do some of my autonomous stuff. However, this will not work, and I will describe to you exactly how this thing will fail. Say that what glitch it will give. Say that right now my you don't after your autonomous selection you selected autonomous mode 1, and autonomous 1 is gonna run. However, in autonomous 1 you have a bunch. You have say that a bunch of motor commands. You have a bunch of motor commands like turn on the motor 1 second or something. So what is a task? A task it basically multitasking is that the use of multitasking is that you can run two streams of stuff at the same time. So essentially, what you're doing right now in this case is that you started a bunch of multi commands. You started this stream of multi commands. However, this thing, the start task, this command only takes like very short amount of time, like far less than a millisecond. And then because this is not a user function, this loop keeps running. This loop keeps running, and your motor mapping keeps going. So that basically what you will see that is if you load this thing to a robot and you press that button, the robot is gonna glitch over there. The robot's gonna keep glitching. Why? Because excuse me, my battery seems to be dying. Alright, my computer was dying, forgot to plug in the battery. Fortunately, spotted that, or I would just lose some file. Alright, so what were we talking about? Say that you load this thing to the robot, and the robot will basically just keep glitching because your driver control motor mapping, if you're not pressing anything, is telling the base or the lift to not do anything, to stay still, or to you essentially keep sending 0 to the motors. However, right here, you are sending a bunch of commands like 1 to 7, like 60, or like 80. You're sending a bunch of those things to the motors. So there are two streams of commands that keep sending those things to the motors, and it's basically updated every 20 milliseconds. So we'll see the motor, the robot keep glitching. Like something tells it to go forward and then stop, go forward and stop, and it's updated every 20 milliseconds. It's going to be horrible. So we need to do something else. So the correct way to do this is that we say we start task autonomous, and then we wait 15 seconds. We have to wait 15 seconds. So wait 1 msec 15000. We wait 1500 seconds. Well, that is pretty good. And however, if you put this thing in, what's going to do is that after I start the task autonomous, it is going to delay 1500 milliseconds, 15,000 milliseconds, 15 seconds, which means that after I start the task autonomous, I immediately pause the user control loop, so that the after I press this button, autonomous runs, and this loop stops right here for 15 seconds. So a bunch of motor mapping is no longer updated. So I only have one task that is correctly operating the motors, which is autonomous, which is pretty good. However, this thing is not the most perfect yet. I mean, you can do it, but it's not the most perfect yet. So sometimes we tend to push the time limit of autonomous. Say that we tend to just to see where we can go, we write a bunch of program. Sometimes the robot gets that cube on the post, or in this case, that's Skyrise talk in this case. Sometimes the robot gets to suck in that ball and toss that ball there. Sometimes the robot doesn't, based on the battery. That's more like nothing but net talk. However, sometimes your autonomous is gonna run for like, if you have some correct timing, or if you use sensor to time. In this case, if you use the sensor to measure the distance that the autonomous is, when your motor starts and stops, perhaps sometimes the autonomous is gonna be a little bit longer than 15, sometimes a little bit shorter than 15. And sometimes if you make a mistake, the autonomous is gonna go like forever if you get stuck in the loop, and that's pretty bad. And that might happen if you are a beginning programmer, or if there's a glitch with the sensor and you don't have protection program. A task, if everything in the task finishes, say that if you have a bunch of motor commands and you finish those motor commands in 15 seconds, the task ends. Which means that if you, in this case, if you only program something you know for sure is going to end within 15 seconds, this is all fine. However, if your autonomous happen to go out of 15 seconds, or happen to get stuck, or happen to be longer than 15 seconds, after those 15 seconds, this loop is going to start running again. So, in those few seconds that's longer than 15 seconds in autonomous, you are still going to get this glitch, which is not necessarily very good. So that, what do? We stop task, autonomous, and we need to stop all motors. Or actually no, in this case, if you stop the task and then the motors immediately gets updated after 20 milliseconds. So yes, so it is very professional and appropriate to place the stop task command after you start a task for for 15 seconds and then to stop it. So probably you wouldn't have known this if I didn't tell you this, but this is the most professional way to do the to start an autonomous in the driver control mode. And basically with this code you just don't need anything, just click button and then the autonomous runs after 15 seconds. No matter the autonomous finishes or not, it forcibly stops everything and cuts back to your driver control. So that's basically a very professional way and a very safe way, the correct way to do your autonomous, just to test your autonomous easily in your driver control mode. And you can change this to anything. I mean, like I just said, you can change this to a bumper. You can change this to a button on the LCD, no problem. So yes, that's it. So that's what I want to demonstrate: the how to correctly start the and test the autonomous with a click of a button in your user control mode. And I hope that is very helpful. This is Smart Mobx Forever, and I will see you in the next video.